This is not some average innovation in the EV industry. Rather, it takes Tesla one step ahead towards their dream of an energy-efficient and sustainable future, without compromising performance. How is that possible, you ask? Well, that's not exactly easy stuff to understand, which is why we are going to talk about it in this video. Since the very beginning, when Elon Musk took the reins as the company's product architect, Tesla has been pushing the boundaries of innovation in engineering and manufacturing. They have been designing their own drive units since their early days as Tesla Motors, and their unique approach has kept them at the forefront of the automotive industry. During Tesla's Investor Day event, automotive expert Sandy Munro and his team observed that Tesla has adopted a hairpin electric motor design. A hairpin motor is a type of electric motor that uses rectangular hairpins instead of round wires for its stator winding. This is a relatively new technology that has gained traction in the automotive industry, with companies like Volkswagen, BMW, and General Motors already incorporating it into their electric vehicles. But why are all the EV makers so interested in it? Simply put, hairpin motors offer several advantages over traditional motors. They utilize larger and differently shaped hairpins compared to round wire motors. The rectangular shape of hairpins optimizes space utilization, making the copper winding about 20% more efficient. This compact design saves materials and provides greater power. The stator windings of hairpin motors have a higher slot fill factor, resulting in a stronger magnetic field and higher motor power. The compact size of hairpin motors improves heat dissipation, reduces consumables, enhances acceleration performance, and lowers noise levels. While the Toyota Prius and Chevrolet Volt have embraced hairpin motors, many other automotive companies have yet to adopt this technology. The design and manufacturing of hairpin motors pose challenges, owing to its complexity and the necessity for specialized equipment. These factors have hindered their widespread industrialization. Cost-wise, hairpin stators can reduce effective material costs by 8 to 12% compared to traditional motors. Taking the overall benefits to vehicle performance and power consumption into account, the use of flat wire motors can lead to cost reductions of approximately 15%. Tesla showcased their automated machinery in action, assembling these motors during the event. However, implementing hairpin technology comes with its challenges, particularly ensuring the accuracy of the bending and welding processes for the copper hairpins. Incorrectly welded hairpin ends can result in electrical losses. Here's where Tesla's ingenuity shines through. They have developed custom software that models and simulates the entire motor, including its rotating electric field. Tesla claims that their software is not only faster but also more accurate than what its competitors use. This capability allows Tesla to rapidly iterate through millions of designs and select the most optimal one. This advantage proves especially valuable in the context of hairpin technology, which is still undergoing intensive research. Additionally, Tesla's expertise in artificial intelligence could potentially contribute to optimizing the hairpin winding pattern, further reducing the motor's resistance and enhancing overall efficiency. Once again, Tesla's software capabilities position them at the forefront, keeping them ahead of their competitors. In addition to its motor innovations, Tesla also excels in chip manufacturing. They produce high-level chips in-house that are unmatched in the industry. Continuously improving their technology, Tesla's charging chip, for instance, reduces heat by 2 times and utilizes a single microprocessor, making the chip smaller and reducing the use of expensive materials. Despite the smaller size, the chip retains, if not enhances, its capabilities. This commitment to pushing the boundaries of chip technology further emphasizes Tesla's determination to stay at the forefront of innovation in all aspects of its vehicles. At Tesla's Investor Day, Colin Campbell passionately emphasized the company's unique vertical integration, enabling efficient communication and collaboration. Tesla's aim is to produce all high-level vehicle components in-house for the next-generation platform, with software integration playing a pivotal role, influenced by their Silicon Valley background. Elon Musk also made another groundbreaking announcement. Tesla's next-generation motor will eliminate the use of rare earth metals, defying previous beliefs. This move not only maintains performance but also reduces costs and increases efficiency. The news had an impact on rare earth miners, causing a temporary decline in stock prices for companies like MP Materials, though they recovered shortly after. These rare earth metals are silvery white heavy metals. If you look at the periodic table, you will find them in Group 17, including lanthanides. They are used in various applications like electronics, lasers, glass, magnets, and industrial processes. But the problem with these metals is that they're found in small concentrations at select locations in the world and require extensive processing, thus giving them the name rare earth. But these aren't the only reasons to sidestep rare earth metals. Avoiding rare earth metals offers multiple environmental benefits. First, it reduces the negative impacts of mining operations, such as deforestation, habitat destruction, and pollution. Second, it conserves energy by lowering the energy-intensive processes involved in rare earth metal production and refining, thereby reducing greenhouse gas emissions. Third, it decreases waste generation, including hazardous chemicals and radioactive materials, simplifying waste management and reducing environmental contamination risks. Fourth, it helps preserve water resources, as rare earth mining consumes substantial amounts of water, alleviating strain on local supplies. All in all, avoiding rare earth metals mitigates environmental risks associated with their life cycle, promoting safer manufacturing processes. That's why, to ensure a sustainable future, Tesla is looking forward to a no rare earth metal era with hairpin motors. The advantage for Tesla lies in the scalability of the next-generation motor, as it doesn't rely on sourcing rare materials with potential environmental and social impacts. While Tesla didn't specify which rare earth metals were previously used, neodymium, praseodymium, and dysprosium are commonly found in their permanent magnet motors. However, Tesla has found a way to function without them, resulting in significant savings. By removing neodymium alone, Tesla estimates savings of $123 million for this year, assuming 2 million permanent magnet motors. As Tesla strives to produce 20 million vehicles, these savings will have an even greater impact. The next-generation motor also utilizes 75% less silicon carbide due to smaller chips, representing another leap in innovation. Tesla's reusable inverter enclosure allows backward compatibility and minimizes drastic changes. These advancements contribute to the next-generation powertrain's significant progress. Tesla aims to reduce costs and redesign components to lower prices for their upcoming vehicles. The next-gen drivetrain is estimated to cost only $1,000, substantially less than competitors. Battery pack costs are approximated at $5,200, based on a $70 per kilowatt-hour price, with an additional $1,000 for the powertrain, totaling $6,200. However, these estimations may not fully capture Tesla's actual design changes. Aligning with Tesla's profitability goals, a more accurate estimate suggests a $4,100 powertrain cost for a $16,000 car, considering a 45 kilowatt-hour battery pack. If you look back in time, initially, Tesla licensed technology from AC Propulsion for the drive unit of their original Roadster. However, they quickly brought the production of these units in-house with the release of the Model S. Today, Tesla's induction and permanent magnet motors are not only advanced, but also highly efficient. The induction motor, which traces its roots back to the legendary Nikola Tesla, is widely acclaimed for its simplicity and reliability. On the other hand, permanent magnet motors leverage magnets to create a powerful magnetic field, making them exceptionally efficient and ideal for electric vehicles. Tesla employs both types of motors in their vehicles, utilizing multiple generations of each. Rear-wheel drive setups utilize the efficiency of permanent magnet motors, while dual-motor versions incorporate an additional induction motor for the front wheels. The distribution of power between these motors can be adjusted to optimize efficiency and torque. The induction motor excels in high-torque situations, while the permanent magnet motor prioritizes efficiency, especially during highway cruising. Notably, Tesla's plaid vehicles, such as the Model S, Model X, and Tesla Semi, boast carbon-wrapped permanent magnet motors that deliver continuous high-power output, unlike other motors that experience a drop-off after reaching peak horsepower. Tesla's next-gen motor, unveiled by Elon Musk, focuses on extreme scale. While prioritizing power, acceleration, and efficiency, Tesla's cost reduction efforts often go unnoticed. Their battery strategy, exemplified by the 4,680 cells, prioritizes manufacturability over energy density. Scaling production and reducing costs make Tesla's approach affordable compared to expensive alternatives. Speaking of cost reduction, Tesla has already made significant strides with its Model 3 motor. Interestingly, this motor is not limited to just the Model 3. It is used across their entire vehicle lineup. Between 2017 and 2022, Tesla managed to decrease the use of rare earth metals by 25%, reduce the weight by 20%, and shrink the factory size for motor production by a whopping 75%. These improvements have resulted in a remarkable 65% reduction in costs. It's worth noting that the cost of the factory itself ultimately factors into the price of the product, as Tesla needs to cover all their expenses. Hence, enhancing factory efficiency becomes crucial to reducing motor costs. Tesla's streamlined approach and vertical integration make electric vehicles cheaper. The next-generation hairpin motor offers cost-effective performance and is likely to replace current motor designs. Tesla's innovations with it and in-house manufacturing give them a significant advantage over their competitors. Brace yourself for the future of automotive technology. Now, we'd love to hear your thoughts on this game-changing innovation. Do you believe this motor will revolutionize the electric vehicle industry? How do you think it will impact the overall adoption of electric vehicles? Tell us in the comments section. If you found this video informative and exciting, make sure to hit the like button and subscribe to our channel for more updates on cutting-edge technologies. Thanks for watching.